This is a video solution for number 5, J, N, and P on page 16 of the textbook. The first thing that we're going to do for J is I'll just rewrite this, but instead of using the cube root, I'm going to rewrite that as a rational exponent. And I'm going to do that for the second factor as well, which is just 5 to the power of 1 over 3. Then I recognize that my exponent on the inside of this bracket and the exponent on the outside of the bracket will multiply. So I get 5 to the power of 2 over 3 times 5 to the power of 1 over 3. And since this multiplication involves bases that are identical, 5 and 5, I can add the exponents. So 2 over 3 plus 1 over 3, which is equal to 5 to the 3 over 3, which is just equal to 5 to the 1, and that's equal to 5. So just to recap, I took 5 squared, got rid of the radical, and did 5 squared to the power of 1 over 3. 5 to the power of 1, or just 5. Then instead of the cube root, again, 1 over 3. I multiplied the 2 inside the bracket with the 1 over 3, and I got 2 over 3 as an exponent. Then because I'm multiplying these two right here, they have the same base, so I'm able to add the exponents to get 3 over 3, which is just 1, and that's equal to 5. In question N, we have 0.027 to the negative 2 over 3 divided by 0.25 to the negative 1/2. Okay, so what you might see is that, okay, this right here has a negative and this right here has a negative, so I can just basically flip the fraction. And that's absolutely true, but I'm going to show you why you can flip the fraction just in a little bit more mathematical detail. Okay, so you've got 0.027 over 0.025. This is raised to the negative 2 over 3, so I'll just put that to 2 over 3, and then I'll put that to 1 over 2, and I can actually factor out a negative 1 from those exponents, right? Because if I use my exponent laws, I can actually redistribute that negative 1, and then I'll get back to the original question, right? So I can factor out that negative 1, and that does, in fact, allow me to flip this fraction. Okay, so I'm going to go ahead and do that. On a assessment, you can just go ahead and flip the fraction, but I wanted to show why that's possible. Okay, so over here, we can just take a look at this right here, 0.25 to the 1/2. Well, that's just equal to the square root of 0.25. And then over here, 0.027 to the power of 2 over 3. Well, I'm going to split up that 2 over 3, and I'm going to do the cube root first of 0.027, and whatever that number is, I'm then going to square it. Okay. All right, so the square root of 0.25 is 0.5. And then the cube root of 0.027 is 0.3. Recall, I still have to square that. So my next line will be 0.5 divided by 0.09. And since we, in general, don't want to combine decimals and fractions, I can multiply the top and the bottom by 100 over 100. And that should get me 50 over 9. This is an acceptable practice because multiplying by 100 over 100 is just like multiplying by 1. Okay, to recap, what I did is I flipped the fraction since both of the exponents were negative. Then I took the square root of 0.25 because 0.25 to the power of 1 over 2 is just the square root of 0.25. Then I took the cube root of 0.027 because, and let me just quickly show this again, that's 0.027 to the power of 1 over 3, then squared. I just split up the 2 over 3 into 1 over 3 and 2. So cube root of 0.027, then squared. Okay, and then I ended up with 0.5 over 0.3 squared, 0.5 over 0.09, multiplying by 100 over 100, 50 over 9. In question P, I have 9 to the power of 3 over 7 times 3 to the power of 1 over 7. And this one's a little tricky because the 9 and the 3 are not equal bases. So I can't do anything with these exponents right now. Can't add those exponents because the bases are not equal. But if I look at that 9 is just 3 squared. So I'm going to go ahead and rewrite the question here. 9 to the power of 3 over 7 times 3 to the power of 1 over 7. And as I just said, that 9 could simply be rewritten as 3 squared to the power of 3 over 7 times 3 to the power of 1 over 7. And recall, if you have an exponent inside the bracket and outside of the bracket, we can multiply those together. So 2 over 1 times 3 over 7 is 6 over 7. So 3 to the power of 6 over 7 times 3 to the power of 1 over 7 is equal to 3 to the power of 7 over 7, which is just 3 to the power of 1, and that's equal to 3.